Welcome. This is Dr. Michio Kaku, Professor of Theoretical Physics at the City College and the Graduate Center of the City University of New York, and this is Exploration. Every week in Exploration, we discuss the fascinating world of science and its impact on society. And today, we're going to do questions and answers. I get literally hundreds of questions mailed to me, either by mail or by email. And instead of trying to answer each one, I like to answer categories of these questions collectively in this first segment of Exploration. But first, before I begin, let me say that the entire world is saddened by the tragic deaths of at least 49 people in Orlando, Florida. It was a tragedy beyond human imagination. Think of that, terrorism, 49 people cut down in Orlando, Florida. It seems that terrorism has become, well, a part of modern life. And it's hard to believe that so much carnage and destruction could be committed by just one person. And so let's all take a moment of silence to honor those people that perished in Orlando, Florida. And now what I'd like to do is answer some of the questions that I get by mail and by email. There's no way I can possibly answer all of them. So what I'll do today is answer large categories of these emails that I keep getting. First of all, people ask questions about, well, life in the universe, life on Mars, life in outer space, flying saucers, and what have you. As you probably heard recently, Hillary Clinton has come out publicly and stated that the United States government should declassify its entire files on UFOs. I mean, after all, what is the government scared of? Little green men? It should declassify its Roswell and Area 51 files. And it turns out that Hillary Clinton's senior advisor was also an advisor to President Barack Obama, where he also argued to President Barack Obama that he should declassify all those files. Well, President Barack Obama decided not to declassify those files, but Hillary Clinton said that, yes, she will declassify those files if she becomes president of the United States. Well, I get tons of these UFO sightings in the mail, but let me say really quickly that I'd say that, about 95% of them can be dismissed pretty rapidly by being natural phenomena. Perhaps they're weather anomalies, the planet Venus, meteors, comets, perhaps all sorts of different kinds of atmospheric disturbances like, for example, swamp gas, and also radar echoes. And so for a variety of reasons, scientists tend to be skeptical about whether any of these UFO sightings have any validity whatsoever. However, the last 5%, well, the last 5% is enough to send the hairs on the back of your head up. The last 5% are very hard to debunk. In fact, I had one of the leaders, the founders of the Skeptic Society on Exploration, and I asked him bluntly, how do you explain the fact that many times airplanes seem to be chased by things flying next to them? It's sighted visually by the pilots. It's also sighted by ground radar and also the crew. So we're not talking about one person claiming that they've been abducted by aliens from outer space. We're talking about multiple modes and multiple observers of the same event. And quite frankly, many of the guests that I've had on Exploration draw a blank. And they don't have an answer other than to say that maybe it's a stealth bomber. Maybe it's some kind of new designed aircraft that the United States military is experimenting with. So those are the incidences which I think can actually send shivers up your spine. And I think it would be a good thing for Hillary Clinton, if she becomes president, to declassify all those files. The other question I get is, well, what about life on Mars? We spent billions of dollars sending probes to Mars. What have we gotten from all this activity with robots? Well, the short answer is not much. So far, we have found no evidence, I repeat, no evidence whatsoever of any life form on the planet Mars. And just remember, the scientists would be glad to become famous by announcing that they have found some evidence of life on Mars, but so far, nothing. Not even the slightest microbial life has been found on Mars. However, We should also point out that liquid water apparently does flow on the surface of Mars. This is something that's a bit of a game changer. We once thought that Mars was simply a frozen desert. Now we know that liquid water can actually flow on the surface of Mars. Not to mention the fact there are many places on Mars that we haven't visited. We have not yet visited the polar ice caps. We have not drilled underground into the core of Mars. Now think about it for a moment. If you are an intelligent species living on Mars billions of years ago, and you realize your atmosphere is leaking off into outer space, you realize that there's only a limited amount of water, what would you do? Well, there are three choices. A, you can leave and go into outer space. B, you can go to the polar ice caps because it snows and what little water is left freezes and will land on the ground of the polar ice caps. And 3, you'll go underground, perhaps living off the warmth of volcano vents. Well, so far we've looked into outer space and see nothing, but we have not yet looked at the polar ice caps, and we certainly have not looked underground for any kind of activity. And then the other question is, what about life in the solar system, not just on the planet Mars? Well, we used to believe in something called the Goldilocks Zone, and that is life can only exist on a planet just right from the mother sun, so that liquid oceans do not boil off if the planet is too close to the sun, and liquid water does not freeze if the planet is too far from the sun. Just right from the sun, water is a liquid, and liquid water is the so-called universal solvent. Outside of some minerals and oils, water will dissolve most things. And as a consequence, it acts as the amniotic fluid that got DNA off the ground. So then the question is this Goldilocks Zone the only place to look for life? And the answer is no. A moon of Jupiter and a moon of Saturn, Europa and Enceladus, may in fact have more liquid water than the oceans of the Earth. Now that seems to be impossible. We're talking about planets that are billions of miles away from the sun. It is ice cold out there in the vacuum of outer space near Jupiter and Saturn. So how can you have liquid water that far from the sun? And the answer is gravity, tidal forces. As the moons tumble in their orbits around Jupiter and Saturn, they twist and turn, meaning that gravity squeezes them differentially, causing friction. Friction in the heart of the moon, causing more volcanic activity, and heating up the temperature of the oceans. So even though these moons are covered with ice, underneath the ice cover we think there is liquid water. In fact, so much liquid water, it may actually exceed the volume of liquid water found on the planet Earth. And so perhaps, just perhaps, if one day we sent an orbiter to eventually land on Europa, a moon of Jupiter, it might find evidence of this, and there's even a blueprint for a space mission to drill a hole in the ice cover and release a submarine. The submarine would then prowl the oceans of Europa, making pictures, perhaps pictures of aquatic life and fish. Well, all of this is still on the drawing board. In fact, the Europa mission has been temporarily shelved, but it does mean that scientists are seriously looking at the possibility of one day sending a submarine to a moon of Jupiter in order to find evidence of any life at all. And then the question is, well, what have we learned about life in outer space, specifically the exoplanets? Well, just about a month ago, the people who run the Kepler satellite announced that the Kepler satellite has identified over 1,000 exoplanets orbiting other stars in outer space. So the grand total is something on the order of 2,000. Think of that, 2,000 planets orbiting other stars in our sector of the Milky Way galaxy. Well, you can extrapolate from that. If you extrapolate from that to the entire Milky Way galaxy, you get an estimate of over 1 billion Earth-like planets in our backyard in the Milky Way galaxy. I repeat, not just 1 million, 1 billion. 1 billion planets, perhaps within our own Milky Way galaxy, capable of sustaining life. Now, most of these planets probably sustain maybe microbial life, not intelligent life, but even if a fraction even if a fraction of these planets have large life forms, not just microbial life forms, and maybe even intelligent life, that could be a game changer. And then the question is, one day, if we ever meet these aliens from outer space, what will they look like? If they land on the White House lawn, come out and shake their hands and wave at us, what are they going to look like? Well, first of all, they may not even be organic. It seems to me that intelligent species in outer space may not necessarily send humanoids. They may send robots. Robots are cheaper. They don't complain. They don't have to come back. And so there are tremendous advantages to sending robots. And so perhaps when the first aliens land on the White House lawn, announcing their existence, we shouldn't be surprised if we find out that they're partly organic and partly mechanical. And then the next question is, well, on the mother planet, what do the aliens look like? Not the robots, but the original aliens. Well, of course, we don't know for sure. However, we can look at the millions of life forms that have evolved from the planet Earth and then isolate the factors which made us intelligent. Well, I think most scientists would believe that at least three characteristics were responsible for making us intelligent, meaning that in outer space, if we have life forms in outer space, perhaps they too will need these three ingredients. The first ingredient is stereo eyes of some sort. They don't have to have just two eyes, but stereo eyes allows them to judge distance. Chances are they're going to be predators rather than prey, because predators have their eyes to the front of their face, and they tend to be smarter than prey. We talk about the sly fox. We talk about the dumb bunnies. And why is that? Because if you're a predator, you have to know how to stalk, how to camouflage yourself, how to ambush. You have to know the characteristics and habits of the prey. So in other words, on all these questions, you have to be quite intelligent. However, if you are the deer, all you have to do is learn how to run. Now, what are we? Predators have eyes to the front of their face because they have to have stereo vision to lock on to the distance to the prey. While animals, which are basically food for the predator, that is the prey, they have eyes to the side of their face because they have to look 360 degrees all around. That's why deer, for example, have eyes to the side of their face rather than the front of our face. Now, we, of course, are descended from predators of some sort because we have eyes to the front of our face. Second, you need some kind of opposable thumb, tentacle, arm, some way to manipulate the environment around you. For us, it was the thumb. Now, the thumb did not originally evolve to be the thumb. Basically, evolution hijacked the thumb so that our thumb became the way in which we can manipulate the environment around us. However, take a look at the octopus. The octopus has tentacles which are quite good at manipulating objects in the environment. Look at the elephant's trunk. So it doesn't have to be our thumb, but our opposable thumb not only made it possible for our ancestors to swing in trees, it also made it possible to create tools. And number three is a language. We want to be able to accumulate knowledge, not the knowledge of one individual, but the knowledge of, well, thousands of generations of wise individuals that existed before you and before your father and mother. And so, in other words, language allows you to hand down information about reality, to hand down the tricks of the trade, to be able to communicate with others so you can hunt collectively as well. And so language is a very, very important characteristic that we need in order to accumulate knowledge, interact with others, hunt collectively, and care for one another. And so what do we expect in outer space? Well, we don't know for sure, but we expect animals that are mobile. They have some form of transportation and manipulation of the environment. A tentacle, an arm, what have you, with an opposable thumb, some way to manipulate the environment. 2, stereo eyes of some sort. 2, 3, 4 eyes, who knows for sure. But some way to lock onto your prey, because chances are predators are smarter than prey. And 3rd, a way to hand down information from one generation to the next, a way to accumulate knowledge and build on that. and that is the function of language. Next, I'd like to say something about the space program, and that is, will we ever be able to go to the planets to begin with? What about the space program? Well, NASA, for many a year, was criticized as being the agency to nowhere. It basically spun wheels around the planet Earth. We got very little science, actually, from the space station and the space shuttle. And we were just basically in near-Earth orbit, spinning around the Earth, not going to the moon, not going to the asteroid belt, not going to Mars. However, we think that's all over. Last year, NASA made it official. They see Mars as a principal target, which raises all sorts of questions because, of course, Mars is very far away. It took about 3 days to go to the moon. To go to Mars, to go and back, would take about 2 years. So we're talking about a very long journey to Mars. Plus, as I said before, Mars is very expensive because it's so far away. It only takes $10,000 to put a pound of anything in near-Earth orbit. So your weight in gold is what it would cost to put you on the space station. However, to put you on the moon would take about 10 times more funds, so about $100,000 a pound. And then to put you on Mars would cost about $1 million a pound. That is the cost of diamonds. So space is expensive. However, people are taking steps to reduce the cost. Elon Musk, the founder of PayPal, the founder of Tesla Motors, and the founder of SpaceX, has said that his real mission in life is to go to Mars. Real mission in life. And that's why he wants to build reusable rockets. And so far he's had 3 successful launches. Not only did they shoot cargo into orbit and around the International Space Station, 3 of them actually went up and landed softly back down on a solid platform. This is amazing. We might be able to reduce the cost of space travel to the point where even space tourists might go into outer space. Now, a long shot that may take until perhaps the end of the century is a space elevator. Imagine going into a chamber, hitting the up button, and then watching as you hit floor to floor into space until you reach the International Space Station. It sounds impossible. It sounds like the fabled skyhook, which of course would violate the laws of gravity. You cannot latch a hook onto the sky. However, a space elevator is actually possible. It was the Russian physicist Velkovsky who did the first calculation to show the centrifugal force, the same force that holds a ball up when you spin it around a string. That same force is capable of being used to keep a space elevator up in orbit. You would need a very specific form of technology, basically nanotechnology. You can calculate that the cables of a space elevator would rip apart because of centrifugal force. However, if you use nanotubes made out of pure carbon, and you do the same calculation, you find that, yes, it is possible to create basically a ladder to heaven. Think about that, Jack and the Beanstalk to heaven. It is possible, well within the laws of physics, but of course we may have to wait till the end of the century before we get the bugs out and before we can actually build a space elevator to the stars. However, when that happens and we can go into outer space, that's going to vastly reduce the cost of space travel and help to focus it in on the future. And then one question I often get is, what's my position on the presidential elections? After all, Hillary Clinton and Donald Trump seem to be the official candidates running for the Democratic and the Republican ticket. And the question is, which do I back? Well, publicly, I back neither. Privately, I have my own private thoughts. But you see, I do a lot of media, and the media sometimes asks me a simple question. Are you Democrat or are you Republican? At that point, I simply say I'm an independent. Because if people were to know that you're Democrat or Republican, then they tend to doubt what you say. They say you have a hidden agenda. Secretly, behind all the platitudes, secretly there's a hidden agenda. You want to promote one point of view over the other point of view, and therefore we don't believe in your science. But you see, science is ultimately answerable to Mother Nature. Not to yourself, not to other people, but to Mother Nature herself. So you better get it right. And so that's why I say to people, well, why don't you back a presidential candidate? That my effectiveness would be a lot less if I were to come out for a candidate, because then people would say, aha, he has a hidden agenda. He's going to spin what he says in one direction. So basically, we don't believe it anymore. And that's one reason for saying that, well, I take no position on the presidential race. However, issue by issue, we can now talk real science. For example, global warming. Yes, global warming is real. And 95% of scientists say that not only is it real, it's also man-made. As far as we can tell, it is human activity that is driving the current rise in world temperature. First of all, the fact that the temperature is rising is no surprise to people. Satellites have detected that for years. And for example, if you're a farmer, you know because your livelihood depends upon it, you know that summertime is roughly a week longer than normal. You know that. After all, you use the seasons to know when to plant the crops and what to do for the planting season. Well, so even farmers know that, and they're quite conservative. And so I think we have to come to the realization that, yeah, even the average person is realizing that something is happening with the weather. Well, another question I sometimes get is, why can't we cure cancer? I mean, after it goes back to Richard Nixon. He declared a war on cancer, and cancer won. So why can't we cure cancer? I think actually cancer will be considered like the common cold. We also don't cure the common cold either. There are 300 varieties of common cold, and each rhinovirus in turn requires its own vaccine, and it's simply too expensive. It's simply too expensive to create a vaccine for every one of those rhinoviruses, and so we simply live with it. No one's going to die of it in the main, so why not simply live with it? Well, that's my attitude toward global warming. In other words, yes, the majority of scientists, the vast majority of scientists say that it is real. It is a phenomenon that has to be watched very carefully, because by mid-century and beyond, we're going to start seeing a lot of cities going underwater. Just look at New Orleans. Look at Venice. They were created in a time when there was boundless optimism about the future of this country. People didn't think about the wobbling of the earth because there wasn't enough sensitive instruments to make that possible. Well, now we do have the instruments, and the instruments do tell us that the earth is warming up. Then the next question is, what's causing it, or who's causing the heating up of the earth? And here we have to look at the European media. The European media has run elaborate articles going through all the science, the technology, the numbers to show that global warming really is a true phenomenon and not just a figment of somebody's imagination. And yet another question I'm often asked is, what is the next breakthrough in terms of cancer? Cancer, of course, is the second leading cause of death in the United States after heart disease. And the question is, what about the new revolutionary developments in medicine? Well, one thing that's going to be hitting the marketplace very soon is the question of liquid biopsies. In other words, if you think you have cancer, it's a long, arduous process. You have to make an appointment with a doctor. The doctor has to invade your body to take a piece of tissue sample called a biopsy. Then you have to analyze it. Wouldn't it be better to simply have a blood test? Perhaps in the privacy of your own home, your own living room, your own bathroom? It's coming. Because of technologies giving us, for example, the DNA chip, it means that simply by analyzing blood in a chip, you were able to analyze the proteins and the genes that are involved with cancer. These are called liquid biopsies, and in fact I write about them in my book, Physics of the Future, and now they're going to be hitting the marketplace. In other words, in the future, perhaps the word tumor will disappear from the English language. Because after all, by the time you have a tumor, you have at least 10 billion or so cancer cells growing in your body. That's an awful lot of cancer cells, and they didn't arrive overnight. Why not have a test that allows you to detect the presence of maybe 100, several hundred cancer cells in a colony perhaps years before a tumor forms. And that's the promise of liquid biopsies, DNA chips, a whole new world of devices and sensors that allow you to catch cancer in its earliest stages. Now, this, of course, could revolutionize the way we do medicine, because this will be available in the privacy of your own home. That's right, these kits you can take into the bathroom, you can perform the blood test, and basically you can bypass the doctor and bypass a lot of the paperwork. Now, of course, there are problems with regards to this technology. Let's say you come out with a positive result. It means that perhaps somewhere in your body there are cancer cells growing, but that's just the first step. Now you have to find out which organ is involved and the location of the cancer cells, which will eventually give you a tumor. That, of course, could be more problematic. We don't have yet the technology to identify precisely where 100 cancer cells may be growing in your body. In other words, you'll be put on alert. You'll be put on alert realizing that, yes, at some point in the near future, in the coming years, you could develop cancer of a certain organ, but it's still too early to precisely identify where that cancer colony is living inside your body. And one last question that I always get is, what about fusion power? Will fusion power one day energize our machines without global warming? Well, there's a joke about fusion power, and that is that every 20 years, we physicists claim that fusion power is just 20 years away, and 20 years later, we have to repeat that same claim. Well, what about the pros and cons about fusion power? The French are going full blast into building what is called the ITER fusion reactor, and we think it could actually be the first commercial application of fusion power into the marketplace, but we don't know for sure. It, of course, is the engine that drives the sun. It's the engine that drives the universe, in fact. All the stars in the heavens, they get their energy from fusion power. Well, we'll bring on our next guest in the next half hour, Professor Charles Seif, who will talk to us about whether or not one day we will have sun in a bottle. So, in the next part of Exploration, we're going to talk about fusion power, the promise of limitless power, almost for free. Well, that's it for the first part of Exploration, but in the second part of Exploration, we're going to bring on NYU Professor Charles Seif, talking to us about the promise of limitless energy almost for free, and that is fusion power. So stay tuned now for the second half of Exploration as we continue our discussion about energy, limitless energy almost for free. Will we ever have it? Welcome. In the second part of Exploration, we're going to get right into energy for the future. When we look at global warming, we realize that there's a tremendous amount of investment in fossil fuel technology, and many politicians are very adverse to weaning our economy away from fossil fuels. Think of the cost. Think of the number of people that might be unemployed. However, some people say that, well, fusion power is a way to get unlimited power almost for free without endangering the atmosphere. But other people say, wait a minute, hold on a second. We're talking about investing in an unproven technology. So with us today to talk about the pros and cons of fusion power is Professor Charles Seif of NYU, author of a book, Sun in a Bottle. Think about that. We're talking about the potential of extracting almost unlimited amounts of energy from seawater. That's right, seawater is the basic source of hydrogen to be used for fusion reactors. And we're not talking about creating copious quantities of nuclear waste, as in uranium reactors. We're not talking about meltdowns, which are also endemic to uranium-type reactors. We're talking about a potentially clean source of energy, the kind of energy that the sun uses. The sun, the stars in the heavens, recycle fusion power in the form of hydrogen and helium. And the question is, can we safely put it on the planet Earth? So once again, with us today to discuss the prospects of fusion power is Professor Charles Seife, author of the book Sun in a Bottle. Professor Seife, you're a journalist. However, you've written about cosmology, and now you've written a new book called Sun in a Bottle, The Strange History of Fusion and the Science of Wishful Thinking. So how did you, as a journalist, get interested in things that most journalists avoid like the plague?
Well, I have to say I'm really a physics geek at heart. Back before I became a journalist, I studied physics and mathematics, and it was only fairly late in my education that I decided that I was more suited to writing than I was to actually performing scientific work. Mm-hmm. So even at the very beginning of my career, I was interested in writing about physics because that's what I loved. And so my career has been covering physics for a decade and change. And from the very beginning of the time that I was writing, among my first pieces was a large piece about fusion. And coming from the physics point of view, I thought of this wonderful thing which would solve the world's energy crises. And as a journalist approaching it, I saw that it was a little bit more complex than I had initially expected with my physics goggles on.
Okay, well, let's just jump right into your book. Your book starts out at some of the hairiest days of the Cold War. In 1945, the United States drops a fission bomb on Hiroshima and another fission bomb on Nagasaki based on uranium and plutonium. But then in the 1950s, a new race emerges, not with uranium and plutonium, but with the hydrogen bomb. So explain to us, what is the difference between the fission bombs that were dropped on Japan and the hydrogen bomb based on fusion?
Well, fission and fusion are two sides of the same coin. In some sense, every atom wants to be iron. It has iron envy. So things which are heavier than iron, like uranium and plutonium, want to split apart in the same sense that a ball wants to roll down a hill. And in the process of splitting apart, they release energy. Fusion, on the other hand, takes light elements. Light elements, in some sense, want to stick together and get heavier, getting closer to iron. It turns out that the fusion end of the reaction is more energetic per atom than fission. That is, breaking apart atoms gives you a lot of energy, but fusion, sticking them together, gives you a lot more. So at the end of the Manhattan Project, when the project ended, the United States had a bomb that used fission to power it. In its simplest form, basically all it did was take two hunks of uranium, stick them together, and wham, you get an explosion. So it was easy to do once you got uranium material to set off the reaction. Edward Teller, a physicist at the Manhattan Project, was very strongly in favor of using the other side of the coin, fusion, because he realized that it would lead to a weapon of unlimited power, and he called it the super. And the idea basically was to use an explosion, a fission explosion, to set off a fusion explosion, which was much greater. And Teller was right. The weapon that he eventually created was vastly more powerful than even what obliterated Hiroshima and Nagasaki. To give you a sense of scale, Hiroshima was about a 14-kiloton explosion, the equivalent of 14,000 tons of TNT exploding in the same place at the same time. The first full fusion test, called Ivy Mike, was 10 megatons, 10 million tons, almost 1,000 times larger than Hiroshima. It evaporated the island it was on. And that was just the beginning. In theory, you can make a fusion bomb as large as you want. The biggest ever detonated was the Russian Tsar Bomba, which was more than 50 megatons of TNT. And after a certain point, it's pointless to get larger because you just wind up lifting a larger and larger column of atmosphere into space, so it doesn't do that much more damage. So even though it promised unlimited power, unless you wanted to destroy the Earth, it wasn't that much more effective at doing damage than a fission bomb. But at the same time, the Cold War was getting hot. The Russians had detonated their first nuclear weapon way before Americans thought they could get it, thanks in part to a spy operation that penetrated Los Alamos. So a panicked America realized, well, we have to get ahead of the Russians and keep nuclear supremacy. So they turned to Edward Teller's idea of a super bomb as a way of staying ahead of the Russian nuclear weapon industry. And as we know, the Russians caught up very, very quickly, and it turned into a nuclear stalemate where each side had so many weapons in their arsenal that they could destroy the world many times over.
And I should also point out that when I was in high school, Edward Teller was actually my advisor. And he actually sort of guided my career in the early years when I was at Harvard. However, moving on now, we have the Cold War in full swing, and people are now used to the idea that there is a bomb 1,000 times more powerful than the Hiroshima and Nagasaki bomb. But other people have said, well, look at Mother Nature. Mother Nature uses fusion to light up the heavens. So now explain to us how Mother Nature uses the process of fusion, not fission, to light up the universe.
Yes, it's fusion is responsible for all life on Earth. The sun is essentially a big ball of hydrogen. It's hydrogen gas, and when it was coalescing, it was compressing itself under its own gravity. And collapsing, compressing objects get hot in general. And so you've got this ball of hydrogen that got hot and dense, hotter and denser. And eventually it got so hot and so dense that the hydrogen, moving extremely fast because of the energy of the temperature, the high temperatures involved, started slamming into each other with enough force to cause fusion reactions. So once you get a big ball of gas large enough to collapse under its own gravity and heat everything up high enough, you get a fusion reaction. And the fusion reaction is what makes the sun shine. These hydrogens getting converted eventually into helium, release energy, and that energy shines out in all directions. That's what makes stars shine. But this reaction is extraordinarily difficult to get going. You need such an enormous ball of hydrogen to kickstart that fusion reaction that it's hard to do. Even a mass of hydrogen the size of Jupiter is almost like a star. The problem is it's not large enough to get so hot that you start that fusion reaction in its belly. So Jupiter is, in essence, everything that a star has, except just that extra gravitational oomph to get it hot enough and tight enough to ignite.
And in fact, in the movie 2010, Arthur C. Clarke talks about aliens igniting Jupiter, so our solar system becomes a double star system. However, Jupiter would have to be about 10 times bigger at minimum in order to get ignition. Now, let's talk about the promise of fusion. Why has fusion hypnotized whole generations of inventors and quacks and top physicists? What is the promise of fusion? Why is there so much interest in it? Why have so many charlatans jumped into the game?
Imagine if you had a sun on your desktop, that in a little bottle you had a fusion reaction going. If you could get this, if you could have something like this, you basically have an unlimited source of energy. Hydrogen is abundant. It's the most abundant element in the universe. It's everywhere. It's in the oceans. Water is 2 atoms of hydrogen for 1 atom of oxygen. So if you were able to tap into the sun's reaction and turn hydrogen into helium and releasing energy in the process, you can turn this virtually unlimited source of fuel into energy for free. And because the fusion reaction, if you manage to get it working in the right way, you could just keep feeding hydrogen in, and helium and energy come out. And helium is clean. I mean, if you wanted to, you could release it into the atmosphere and it would float up into space. And so this promises, in theory, unlimited energy with unlimited fuel and no waste. Reality is not quite as simple as that, but that is the promise.
Okay, and for Spider-Man fans, for those people who saw Spider-Man 2, Dr. Octopus creates fusion in his laboratory in Manhattan, which is not the place to do it. But the machine looks like a little sun. It looks like actually a star, and you can see sunspots and solar flares on this miniature sun. However, in real life, we don't expect to create a miniature sun like in Spider-Man 2. What will a fusion reactor really look like?
Well, there's two main areas that mainstream fusion researchers are looking at to make a real fusion reactor, and they are lasers and magnets. Lasers are a very clever way of getting the heat and pressure that you need to take a hydrogen pellet and make it collapse and start fusing. Basically, you shine laser light from all directions, and you squash a tiny pellet, and as it squashes, it compresses, and hopefully it ignites. And if you manage to get lasers that are strong and efficient enough that you create more energy out of that collapsing, fusing tiny pellet of hydrogen than you consume by getting the lasers going in the first place, then you've got a source of energy. You've got a fusion reactor. No one has gotten that far, but it is theoretically possible. Another method is using magnets. It turns out that magnetic fields affect fusing plasmas like hydrogen. And if you shape a magnetic field right, you can create a bottle with which to contain a very hot cloud of hydrogen. And so a magnetic donut shaped right and with a cloud of hydrogen you throw heat in, eventually you might get a fusing plasma. And once you get that reaction going, you just have to figure out a way of piping new hydrogen in and piping fused helium out, and you've got a source of energy going. Again, these magnetic bottles aren't working to the point where you get more energy out than you put in heating the plasma and containing it. But in theory, if our magnets improve and our knowledge improves over time, you might have a magnetic bottle that contains a miniature sun.
Okay, now, because a fusion machine would use ordinary seawater, which is limitless pretty much, as the basic energy source, and because the energy released is almost limitless, the number of charlatans and quacks that have gone into the business is quite large. So let's talk about some of the false starts and some of the dashed hopes. Beginning with Dr. Richter, but the list is long, let's talk about some of the false starts.
Yes, the goal is so lofty, that the unlimited energy, that the idea of fusion has attracted quacks and hoaxers and genuine scientists who are misguided from the very beginning. In 1951, the world was absolutely stunned to headlines that Argentina, of all places, had solved our energy problems forever. There was a German expat named Ronald Richter who had convinced Juan Perón to fund a research laboratory on a secret island in the middle of a lake to get fusion reactions going in what he called a solar thermotron. And he kept the world going for about a year. People were arguing back and forth. Could he have done it? Could he not have done it? It turns out Richter was barking mad. He would get this wild look in his eyes and dump a whole bunch of gunpowder into his experiment and blow the doors off of his laboratory in gigantic explosions and rush out and write fusion on a piece of ticker tape. And yet, for many months, he kept Juan Perón's government believing that he was on his way to solving the world's energy crises, and this would be a great prestige for Argentina. Eventually, physicists in Argentina convinced Perón that something was going on that was a little fishy. They went and visited the laboratory with their own Geiger counters, and if in fact you have fusion reactions going, you should be able to detect neutron radiation coming off, and they detected nothing. So they proved that Ronald Richter was he wasted between $4 million and $70 million of the Argentinian treasury in the process of pursuing his dream. And he disappeared off the world stage very rapidly, as you can imagine. But, in fact, everyone who is involved in fusion in some form winds up deceiving themselves or deceiving others about their achievements. In 1958, British scientists at a very, very prestigious lab built this machine called Zeta. Zeta was a magnetic bottle of sorts, and the scientists had convinced themselves that they had gotten fusion in a laboratory. And they cracked open beers. They announced to the world that they were on their way to solving the world's energy crises. Turns out that they were wrong, that they were not seeing fusion, that they were deceiving themselves with neutrons. They were seeing neutrons, but it wasn't from fusion that they wanted. So they had to humiliate themselves on the world stage. After all these tabloids said energy to last a lifetime, no more energy bills, the British teams had to say, well, not really.
Okay, now more recently, we had this huge fiasco concerning two chemists, Pons and Fleischmann, who grabbed world attention, covers of, I think, Newsweek magazine and the New York Times, and everyone was talking about, well, did Pons and Fleischmann create fusion in a bottle? Not hot fusion, the hot fusion of lasers and magnets, but cold fusion. So tell us a little bit about cold fusion.
Yes. In 1989, two chemists, one of whom was extremely well celebrated, made this announcement to the press that absolutely stunned the world. They claimed that where these hot fusion, this magnetic fusion, this laser fusion research has been failing for years, wasting tens of billions of dollars, these two chemists, working independently, had spent $100,000, and they had solved the problem. And what they argued was that they managed to pipe hydrogen into a chunk of metal, of palladium, which has the interesting property that soaks up hydrogen like a sponge. And the theory was that if you get enough hydrogen in there, the hydrogen will be forced so close together that they might be forced to fuse. And in doing the research on their own, they thought they saw more energy coming out of their palladium cell than was going in. So they thought they had created a device which was creating fusion energy. So as you can imagine, as soon as this was announced, it was headlines everywhere. Cover of Time, cover of Newsweek, New York Times, Wall Street Journal, everywhere was talking about this for months and months and months. It turned out that the scientists were deceiving themselves. There was a bit of fishiness. Some data was moving back and forth. It's uncertain exactly what was going on, but when the cells were reproduced in better circumstances with more sophisticated equipment, it turned out that there was no excess energy, and more importantly, there were no neutrons coming out. Turns out when you fuse heavy forms of hydrogen together, you expect neutrons to fly away, and neutrons are a sign of fusion. They were seeing no neutrons, and that made it pretty clear that nothing was actually happening. However, it took it was a huge battle for years. Physicists versus chemists became a red state versus blue state thing, where the liberal elite physicists on the East Coast were trying to tear down research from chemists at the University of Utah. So it became a huge political battle that still affects the physics community on some level.
Now, you can simply calculate, using the back of an envelope, the neutron count that would occur if they really had fusion in a bottle, and it's sufficient to kill them. So the very fact that Pons and Fleischmann are still alive means that they could not possibly have attained fusion in a bottle. But then the question is, well, what did they attain? They did get net energy coming out. That's been verified by different laboratories. Some people have gone back to the literature on palladium. Back in the 1800s, it turns out that a person applied for a patent for one of the first cigarette lighters. He used palladium, put it in water, and attained a net amount of energy, which he used to light a flame, and he got a patent for it, a palladium cigarette lighter. And some people think that that's what they discovered. Well, what are your thoughts? It's been several years since then. What did Pons and Fleischmann really have in their bottle that gave energy? Was it a cigarette lighter or what?
It's really hard to tell. Palladium has an extraordinarily interesting chemistry. It has been fooling researchers for years, as you've noted, that not only is there that patent, a number in the early 20th century, two researchers thought they had achieved fusion in palladium. And because they were thinking along the same lines as Pons and Fleischmann were, and they thought they detected helium inside, an excess of helium inside palladium, which would be a nice sign of fusion because you're creating helium. It turns out that they were deceiving themselves because it turns out palladium soaks up helium just as well as it soaks up hydrogen, so you have enriched helium. So if they were seeing excess energy, and it's not entirely clear from the setup of the experiment that they were, I mean, they certainly thought there was some sloppiness, but it's certainly possible that they were seeing it. It would most likely be a matter of chemistry, a chemical reaction where bonds are breaking, rather than a nuclear reaction where bonds in the center of a nucleus are being formed. The nuclear bonds that change atoms into other atoms are what are changed in a fusion reaction, as opposed to the attachments between atoms, which are chemical bonds, which are being changed in a chemical reaction like burning paper or cracking water. And so whatever they were seeing almost certainly was a chemical reaction. And chemical reactions are well studied, and there's only so much you can do for solving the world's energy problems with chemical reactions. In fact, burning gasoline is an extraordinarily efficient chemical reaction that allows us to power our cars. So it's not certain that there's anything there for solving the world's energy problems unless you have a nuclear reaction of some sort. It's pretty clear that that is not what they saw.
Now, to a physicist, it was absolutely staggering that you had these two respected chemists that didn't understand anything about the quantum theory. If you bring the protons together very closely, as you mentioned, then you could attain fusion. But you have to bring them really close, 10 to the minus 13 centimeters. However, in the Pons and Fleischmann experiment, these atoms were separated by 10 to the minus 8 centimeters, and you can simply, using a back-of-an-envelope calculation, this is what we give our undergraduates. Our undergraduates can calculate that the fusion you get in a bottle is almost zero as a consequence. So for the physics community, what was absolutely staggering is the fact that chemists don't know any physics at all. Well, let's move on, because we had a story, another apparently fraudulent story that just took place a few months ago, this time at Oak Ridge National Laboratory, involving something called bubble fusion. So explain to us, what is bubble fusion, and how did the Nazis, of all people, first stumble onto this whole thing called sonoluminescence?
Yes, sonoluminescence is this really bizarre reaction, and it's only very recently been understood, where basically you take sound waves and you bombard a liquid with it, and you induce what's called cavitation. Under the right circumstances, if you hit water very hard, it actually behaves like a solid, and it can crack, and just for a tiny fraction of a second, you can cause a crack in water. And what happens when you have that crack is you create a little vacuum, and that vacuum causes water to evaporate and causes a bubble. By bombarding liquids with sound waves, you cause these bubbles, and if you time those sound waves just right, you can cause those bubbles to collapse very dramatically. And it was discovered that if you do this just right, you get such a dramatic collapse that you get some sort of reaction. No one quite knows exactly what it is, even today, that causes a little flash of blue light. So if you turn off the lights and you bombard a tub of water with sound, you can actually get tiny little lights. And it's poorly understood, but it's really cool. You've got a mechanism for compressing and heating something, and a gentleman out at Oak Ridge named Russi Taleyarkhan came up with a clever idea of how to get enormous bubbles by shooting neutrons into the liquid that would collapse dramatically. And his hope was that by having this dramatic collapse in heating and compression, you might actually induce fusion.
Well, I'm afraid that's it for Exploration. Once again, you've been listening to Exploration with Professor Michio Kaku, and our special guest was Professor Charles Seif of NYU, author of the book Sun in a Bottle.